Then section 6.3 is about sample statistics. It's basically just how to summarize your data now with numbers. So we did graphs, now let's do numbers. So again, remember, a statistic is just some value we can calculate from the sample. Now our statistic is technically a random variable because we don't know what value we're going to get until we take our sample. So that's why I keep saying a random variable. But we'll use our statistic to estimate information about our population. Again, we're just going to reword it. A sample statistic then is some kind of numerical data summary of our sample data. Some useful sample statistics we might look at would be like the sample mean or the median, standard deviation, variance, etc. So the first thing we talk about is how do we measure kind of like the center. So you might talk about the sample mean or the average value. And how do we find average? Hopefully you've done this in some other class at some point. To find the average, you add up all your values and divide by n, or how many there are. If you want a nice mathematical formula, you can use the summation of each xi value from 1 to n and divide by n when you're done. But I usually just look at the first formula. Just add them all up, divide by n. Your median is your middle value. So that means half of your observations are going to be smaller than it and half are bigger than it. If you have an even number, you take the average of your two middle values. And sometimes this book does what's called a trimmed mean. Because we find that these outliers kind of really affect our data. And sometimes we really just kind of want to know what's more the typical value and not the true average. And so what you could do is you could take out the top 5 largest and 5 smallest observations and then find the mean, and that kind of gives you a more typical value. And the mode is the data value that shows up the most. So let's try this. We have scores from a first exam for 10 students. Okay, here are all of our scores. Let's find the sample mean. So all we have to do is add up all the x's and divide by how many there are. So in our case, we're going to have 80 plus 73 plus 92 plus all the way up to 90 divided by, let's see, I guess I told you 10 students, so divided by 10. And so if I add them all up, I get 821. Divide by 10, we're at 82.1. So that's the average from that first exam. Now let's find the median. Before you find the median, you're always going to want to write it in order. So find your smallest one is, let's see, 55. And then next is 73, 75, and since I did this earlier, 80, 80, 85, 90, 92, 93, 98. So now for the median, we want to find the middle number. Okay, so I usually kind of tick them off from each side. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Wait. I must have done that wrong. 1, 2, 3, 4. Oh, there's 5. So it should be, there's 10. There should be kind of 5 on each side. I couldn't find an actual middle number because it's even. So what it is I put a line in between my 80 and 85. And we'll say our median is the average of 80 and 85. So 80 plus 85 divided by 2 gives me 82.5. So that's my median. The median is your middle number. So next, let's find our sample trimmed mean by removing 20% from the top and 20% from the bottom. Now this is because I told you 20%, otherwise I might say do it for 10%, 5%, etc. Let's see, 20% of 10 observations is going to be what? So 20% times 10, 0.2 times 10 is 2. So we'll remove 2 from top and bottom. So once again, have them all written out in order. So I'm going to just write them down again. It's 55, 73, 75, 80, 80, 85, 90, 92, 93, 98. So before we find the average, we cross off the bottom two and the top two. And now find the average. So we'll do an X bar again, and we'll put this trimmed. I'll just write trimmed there so I know it's my trimmed average. So we'll add up everything that's left: 75, 80, 80, 85, 90, 92, and divide by how many there are. I think there's 6. So we get 83.66. So far I have my average is 82.1, my median is 82.5, and my trimmed mean, if I take off kind of those more extreme values, is 83.66. The trimmed mean doesn't really come up that often, but it can be useful, again, if you kind of have some weird values. And find the sample mode. The mode is what value do you see the most. So look at them when they're all in order here. And anything that you see more than once, I see 2 80s, so that's the most common value, so 80 would be my mode. So let's try it again. If you turn the page, notice this is the same data set. But one student didn't take the exam and his score is 0. Now this happens all the time when you guys take exams and someone skips it, and I go to find the average in Excel and my average is much lower than it should be because there's a 0 in there. So let's see what adding the 0 in actually does. So first, find the sample mean. So I'm going to add them all up and divide by how many there are. So in this case, we added one more student, so we now have 11. So we still have 821 divided by 11 gives me 74.63. To find the sample median, I'll go ahead and write them in order again. So they're written out in order. Now I want to find the middle value. Okay, so sometimes I tick them off, sometimes I put my fingers on each end. Go 1, 2, 3, 4, 5. So it looks like I have 5 on the bottom, 5 on top, and 1 left in the middle. So if I circle the 80, I have 5 on the bottom, 5 on top, so that's in the middle. So my median is 80. And to find the sample mode, I still have 2 80s. That's the most common value, so 80. Now, let's look at what our results were previously. So previously, in example 163, we had 82.1. The median was 82.5, and the mode was 80. So let's see how they changed. When I added in the 0, my average went from 82.1 to 74.6. That's a big drop, right? That makes it look like the class did much worse than they really did. The median went from 82.5 to 80. So it did change, but did it change as much? It didn't change very much. The mode didn't change at all. So you have what's called resistant measures. The mean is not a resistant measure of the center of your data because an outlier, like the 0, or even observations and kind of like the tail, the more higher low values, can pull the mean towards the tail. So the mean changes a lot. If you add in outliers or extreme values. The median, though, is very resistant. It doesn't change very quickly. And just remember, an outlier is some observation that doesn't fit with the rest of the data. So in this next example, take 2 minutes and find the mean and median for these 2 different data sets. So these are the data sets of salaries of randomly selected professors, and then I added in the basketball coach that gives you. Okay, so find the mean and median, and we'll compare them. Okay, so without the basketball coach, you should have got a mean of 91.4, and for your median, 91 is right there in the middle. And notice our mean and median seem pretty close. Now with the basketball coach, though, if you add in the $650,000, notice that your average jumped up to 161. So your average went up $70,000. Does that seem like a fair way to represent it? Like if you're telling people, come work at USU because we'll give you an average of $161,000, that just doesn't seem very fair, right? But the median stayed at 100.5. Now 100.5 because you had 4 on the bottom, 4 on the top, so you have to do the average of 91 and 110 and you get 100.5. And so again, notice here the mean changes much more than the median. And so if you are going to have outliers, lots of times that average, even though the average is such a common thing that we use, the average can be misleading. Sometimes the median is much better. So the mean changed much more. And the median would be a better measure of what you might call the typical value. So if you were trying to tell people kind of what might you expect to get as a salary at USU, the $91,000 is probably going to be a much better way to measure what the typical person is getting, because not very many people get the basketball coach salary. Now again, with all of these measures of the center and what we're going to learn about next, measure of spread, we're going to do this all with software. So you need to see it once, kind of understand how it works. You might do, like I might ask you to find the average of just a few values on the test, but for most of it, we'll use software because it just takes too long to do by hand. So we talked about measuring center, now we want to measure spread. There's different ways you can do this. The first is range. You probably did this back in elementary school, middle school, some point, which is just the difference between your largest and smallest values. Okay. Or we talked about your median, which is like half your data is below, half is above, so it kind of cuts it in half. You can do quartiles, which is you divide your data into 4 equal parts. Instead of 2 parts, you divide it into 4 parts. So 25% are in each part. Now, if you put those things all kind of together, you can get what's called the 5-number summary, which has your minimum, or the smallest, first quartile, the median. Notice that median is the same as the second quartile, because the median cuts in half and second quartile would be 50%. Okay, third quartile and maximum. So this is actually how you do a box plot. The box plot has your 5-number summary. So smallest value, the 25th percentile, your 50th percentile or halfway, 75%, and your top value. That's how you do a box plot. And also interquartile range, IQR, is just the difference between your upper and lower quartiles, or first and third quartiles. Not one we actually use very much anymore. So for this set of data, let's make a box plot. We have salaries 47 up to 137. So to do a box plot, you need to know your 5-number summary. So minimum, first quartile, the median, third quartile, and maximum. So minimum is easy to look at that list, which is in order, and see that the smallest is 47. Your biggest is 137, so that would be your max. Now then you find your median, so you want to find your middle value. So it looks like we have 7, so the middle would be about this 91, right? So 3 below, 3 above, so my middle is 91. Now once you have the middle value, then you look at everything that's below. So now it's like you have a new data set and you find the middle of that data set. So the middle of that data set is 57. Then you look at all the numbers above, and that's kind of like a new data set, and you find the middle of that data set, which is 110. Now do a number line. Let's do 40, 50, 60, all the way up to like 140. Oh, I skipped 100. So we need to go up to 140. So to make a box plot, you do a whisker, or yeah, you can call it a whisker. Do a line at your bottom number 47 and a line at your top number of 137. And you kind of then have your whiskers coming off of those. Then I like to do my box, which goes from 57 to 110. So here's 57 all the way up to 110. And you put a line at your median. So 47, 57, 91, 110, 137. Or sometimes I just put a line at each one of those 5 numbers and then do a whisker in your box and a whisker. When you look at this, does this look symmetric? Or is my box the same? Or, well, I guess is my box symmetric? No, this left side is bigger, so you know that this isn't a symmetric distribution. In my next example, now remember how we put in the basketball coach? So here's my little box plot down here, and then here's the basketball coach way up here at 650. Now because we kind of suspect that he's an outlier, sometimes we don't do the whisker all the way up to the 650. We'll do the whisker to the next highest value and just put a little dot here at the 650. And so this was actually made using software. Okay. And so when you want to use the software will usually calculate the outliers for you, and they'll mark them as little dots. And we'll actually see some other examples of that. And basically, we mark outliers separately. If we didn't mark the outlier separately, then it seemed like we had one really, really, really long whisker, and my distribution would look inaccurate. Then we're going to kind of switch gears just a little bit here. So below we have a sample of service times for 2 different service centers. You can see the repair days. So my first garage is going to take between like 3 and 5 days. Seems like it's pretty consistent, 3 to 5 days. The National Service Center, though, has it spread out from between 1 day all the way up to 7 days. You can see the actual numbers, 3, 3, 3, 4, 5. Those are the actual data sets. Now, both service centers have a mean and an average, or a mean and a median of 4 days. But are the 2 data sets going to be the same? So, like, which garage would you guys want to send your car to? Now, this is personal preference. You can say either one and be correct. But someone tell us which garage you want to send your car to and why. So now we're just going to kind of review a little bit. Okay, we're going to look back at some box plots and histograms. And on this first page, we're going to describe the distribution based on like shape. Is it symmetric? How many modes does it have? And also talk about maybe outliers. So when we look at number 1, look at the box plot first. Do you notice how they kind of have like a dashed line, some dots, another dashed line, and some more dots? Okay. What that means is the ones here, it means those are definite outliers. And the ones in between the 2 dashed lines are possibly outliers. So your software again will mark that for you. Now this lower thing is a dot plot. We haven't seen those yet, but basically it just puts a dot for each data value. So it's like a histogram. Okay. And you can kind of see where are the most prominent outliers. Like these 2 definitely look like some very bad outliers, right? I could tell you for sure those are outliers. And then if I was looking at it, I'd probably think like, well, maybe those are outliers, but these ones definitely are outliers. So the software has a better eye for that than I do just by looking at it. And here's the histogram. What would you say about this shape? What kind of skew is that? It looks like it has a long, right tail, so right skewed. I would say it only has one mode, so unimodal. And we've got some definite outliers going on. You can even see just this one little rectangle there that looks like an outlier in the histogram. So different representations will make it more or less obvious which ones are outliers, but we can definitely tell that we have some outliers. This next one, let's see, I look at my box plot, I'm not seeing any outliers. Dot plot doesn't look like outliers, histogram doesn't look like outliers. So no outliers. What about the shape? If you look at the box plot, do the two whiskers seem about the same, the two halves about the same? Like everything on the box plot looks fairly symmetric, right? The two halves are the same. And when I look at the histogram, I don't see like a longer left side, longer right side. It looks fairly symmetric. It's not exact, but we'll say roughly symmetric. Most things aren't exact. How many modes would you say it has? Okay, I would say 2 modes, so bimodal. That's a lot easier to see in the histogram than the dot plot. The dot plot, the bins are all too small, so it's hard to actually see your modes. And obviously in a box plot, you can't see modes at all. Let's see, my next one. Notice that we have some possible outliers here. Do these seem like they're as bad of an outliers as number 1? Okay. No, and in fact, I would say these are kind of maybe some possible outliers. They don't quite seem to be as far away from the rest of our data. I can't even see them as outliers on the histogram. Let's see, as far as shape, it seems to be fairly symmetric. And I only have 1 mode. So unimodal. Let's see, number 4, it looks like a couple potential outliers. And looking at my box plot, that doesn't look very symmetric, right? A long left tail here, not symmetric. And when I look at my histogram, it kind of looks like that long left tail. So I'm going to say it is left skewed. Now the question is, how many modes does this have? Okay, go ahead and just shout out how many modes you would say it has. None. You're always going to have at least, well, no, you wouldn't have to have one. But I don't know if I'd say none, because this does seem to be higher. So it is at least 1. But sometimes people argue with me that this one has 2. So they say like there's kind of a peak and there's kind of a peak. So this one could be 1 or 2 modes depending on how much you want to argue it. I'd probably be more inclined to just like 1 mode, because this one's not really that much of a peak, but you could argue 2 modes and I would probably be okay with that. But I do think it would at least have kind of a peak there. And in our next example, now we're going to compare 2 different box plots for each one, and we want to measure their center and spread. Now when you look at box plots, they measure center with the median and the spread with the interquartile range, which is basically the width of the box. Not the whiskers, but the actual box. That's how your actual box plots are measuring the spread. So when you look at these two, your middle line in the side of the box is the median. So it looks like data 2 has a much higher center. It's kind of, the actual box plot is higher up. Now not the bottom whisker, but the middle of it is higher. Okay. And what about spread? Which one is wider or more spread out? Once again, data 2 seems to be more spread out. So it has higher center and spread. Just a sec. Let's see, number 2, if you look at these, notice that the medians, or the middle line here, seems to be about the same. So they have the same center, or median. But it looks like the second one has a much bigger spread. The data is much more spread out, a bigger box. So NSC has a higher spread. And number 3, looks like my second one is much lower. So let's call these A and B. So A has a higher center. But which one is more spread out? I agree. I do think that they have the same spread.